We are doing extremely well. Once again, I am before you with another video of Line 75 series, and it is going to be 14th video from this series and fourth one from strings. And today's problem is valid anagram. Let's get started. It is saying that we will be given two strings S and T, and we have to return true if T is an anagram of S and false otherwise. Okay, and now you may ask me that what is anagram. Let's discuss it. Anagram. In problem, they are saying that we have to find out T is an anagram of S, but we can find out as S as an anagram of T. Both are same thing. What is anagram? Anagram is a string or a set of strings. Suppose I have strings which contain four letters B, E, Z, U. Now, if I rearrange the letters from this string, I can get another string, but always it is going to have four letters. So the first point in anagrams are that they are of same size. If I rearrange, if I write this B here, this E in the starting, then Z, then U, both are different words because it is starting with B, it is starting with E, but they are containing the same set of letters, so they are anagram. Suppose if it would have been two Z's, then its anagram will definitely have frequency of Z as 2. Z will be anywhere, it can be in the starting or it can be in the end. So now again these both strings are anagram. So anagram is nothing if we rearrange the letters of a string and write it down, it will become its anagram. If I have two strings S and T, then frequency of each letter A, B, C till Z here, and frequency of each letter here also must be same for each letter. If it's come three times here, here also it must come three times. If B comes two times here and one time here, they are not going to be anagram, it must be two only. And we'll check from A to Z, and we can simply say that we can find out whether they are anagram or not. So there are two approaches of finding out whether two strings S and T are anagram or not. First approach is going to be by sorting. We know that these both strings are containing same set of letters. If we sort them, these both become equal, but it will take time complexity as n log n, where n will be the size of given strings, and we know that sorting takes time complexity of n log n, and here we need not to take any space, so space complexity will going to be order of 1. In other approach, we will count frequency of each letter as we have just discussed. We will count frequency of A, B, C till Z here also, and we will compare them. If the frequency of each letter is same, we will simply say that these both strings are anagram of each other, but here it is going to take order of n time complexity and order of 1 space complexity, as we are going to store only frequencies for a fixed number of character 26, no matter how big is the input size. Our space will be always be 26, so it is not affecting by input size, so space complexity will be order of 1. Alright, now we will try coding it with both the approaches. First I will sort string S with the sort function And similarly I will sort t string 2 t dot end. In C++, we do sorting like this for strings also and for vectors also, and we can simply return here as same as t, and we can compare two strings with this equality operator. This is it. Running it to see if these both strings are same, it means that they are anagram, and this expression will return me true, and the same will be answer of my function is anagram. It is taking too much time. let me uh, Let me reload this. What happened? Taking too much time. Let's refresh it again. I have checked, Wi-Fi is working fine. It should work. Yes, a code has come. Let's submit it. Taking too much time. What is wrong with it? Yes, it is accepted. Now we will try with the another approach. Here I am going to use a vector int for counting frequency. Purpose of this vector is for counting frequency of each character in both the strings, and as we know that there are only 26 letters, and here in constraint it is given that we will be only having lowercase English letters in input. So we can work with a vector of size 26, and initially value at each place at each index in this vector will be 0. Now I am putting this for loop for iterating over the first string, that is s, and I will count here frequency of character like this. When I will encounter any character, I will increase its count which was initially 0 here, by 1, and at the end I will get frequency of each letter that comes in S. Similarly, I will do with the T, auto I colon T, and I will do frequency I minus minus. So what I am doing here, this is my vector of size 26, so it will have 26 places for storing the frequency, and each place will have some index number like this, and last one will have 25 because its size is 26. Last index will be size minus 1, and here 0 index will count the frequency of small a, 1 index will count the frequency of small b, c, d, and 25th index will last, and that is the last index, it will count the frequency of z. To make changes is at this index we need array name, and in square brackets we need 0 here, then only we can do plus plus. How can we get 0? We can get 0 like this. If we do I, that is the current character, minus small a, these both if a comes, for a, if a comes, a character minus a character, as it is placed in square bracket, it will implicitly convert to integer 0, and we will reach here and will do 1. Similarly for v, 1 will come, and for z 25 will come. If we subtract, if we are subtracting from a will be having some ASCII value that will be subtracted from ASCII value of I character. I will contain some character, its ASCII value will be subtracted from ASCII value of small a. Alright, in this way we can do like this, minus a. Now at the end, so I have increased 1 by 1 frequency of each character while iterating through S, and while iterating through T I have decreased frequency of each character by 1. So if they are anagram, after these both for loop, our vector must have all the values as 0. If frequency of any character is greater than 0 or less than 0, it means that the frequency of each character is not same in both the strings. So we'll simply put here a for loop that will start from 0th index of vector, and it will go till last index. So I have done here less than 26, so I will reach at max 25th index, and here I am checking if frequency I not equals to 0, then straight away I will simply return false, they are not anagram. And if I reach at the end, means false has not yet returned, it means that they were anagram, and I can safely return true in this case. This is it. This is the whole code for this function. Let's try submitting it. Yes, it is accepted. It is working absolutely fine. Hope you understood the concept. This is it for this video, and I am going to see you in the next video. Till then, take care. Bye bye.